Welcome to another video. Here in Canada, it is, well, in Alberta, it's Family Day. In the US, I believe it's Hail to the King, President Day. Wait, we can't have presidents as kings. No. Anyway, I got the panels working on these things. So this board here, it's kind of hard to see, but there it is. This is MicroPython running on the Pico. So I did this first, and I was kind of correct in one thing. Their description of the pins isn't correct. So they would have us believe, here, let me show you, that these were the pinouts for the screen and stuff. It turned out it's not 100% correct. I end up turning around and converting the MicroPython. And if you look at the MicroPython code, I think I have it in here. No, I don't. If I bring up Thonny, and let me go back to here, and I bring up Thonny, let me just shrink this a little bit. So this is the MicroPython code for this. If we scroll down a little bit, we see 6, 7, 4, 13, 14, 15. But if we go over to the pinouts, and here, 6, 7, 4, there's a 7, there's a 6, there's no 4. But there is a 13, 14, 15. 13, 14, and 15. The two greens and the blue, right? LCD WR, LCD CS, LCD reset. And it seems to me what's happening here is they're first making an SPI connection to the board, like so. So the MISO, the MOSO, and the clock pin. And those you can see at the top of this thing are, there's the clock pin, there's MOSI, there's MISO. Pin 8, pin 11, and pin 10 on their chart. But to these guys, here, it's not. It's 6, 7, 4. So they would have MOSI on 7, and over here, MOSI's on 11 on the chart. They would have MISO on 4, and MISO over here is 8. They would have clock on 6, but clock is actually 10. So that was what's real. It was really screwing it all up. So once I put this all in. By the way, Thony's not the nicest of editors. I really prefer the CircuitPython storage system. This one, you have to pick files and then push them to the device by copy them from a serial connection. It's But if we go to the CircuitPython one now, and that one is working. Bring it over here. So this is the CircuitPython one demo that I found. Some guy, he ported the whole MicroPython demo. There's supposedly a this is the demo. It's just a screen drawing, and then there's a general demo of a bitmap, and then there's a demo of a touchscreen. I haven't tried the other two yet, because even in this code here, I had to do some edits. So we see this 13, 14, 15 here. We see the 6 and 7, and then they don't use 4. Go figure. MISO's not used. Probably maybe in the touch it is, but I don't think in the just plain display. Now, a lot of this code too, they had lines like where was it? Here, display IO group, for example, right? They had the old limits parameter in here. That doesn't work anymore. This whole function has changed over time. Now it's the scale function. So I had to go through and here correct a whole bunch of these ones where it says scale, 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 scale. Right? But I got it working, so that is working. And I can now actually move on and do some other stuff. And the REPL shows up in here and stuff like that pretty nicely. Now, I haven't played with the sound or the buttons on here or anything else like that on here. So K4, K3, K2, K1, for example, I haven't played with them. So, but it's working. So that code came from, let me see if I can find it here. So that came from this guy right here. So it's the same thing I've got here. Well, it's the same screen as this. Okay. That one there is just not attached to this breadboard, but it's exactly the same screen using the same pinouts and stuff like this. So what I had to do in this code is tweak it a little bit. So this code here is the driver for the screen if you don't already have it. And this code here is the one I was working on. This is just does the display. So if we go down here, it says GP 13, 15, 14, 7, 4, and 6. Yeah, I found that it matches what this breadboardy thing is doing exactly. And it works. Now, as I said, in his code, he had max size here. It's this guy right there. So that max size, that parameter doesn't exist anymore. What's Sony complaining about? Nothing. Okay. So I haven't tried out this one here, which is the bitmap. And I haven't tried out this one, which is the touchscreen yet. This is a little more extensive. I've already got the code on the drive and everything. I just have to rename the file, for example, and then correct for, again, that particular parameter that's not supposed to be in there. And it should work. So, but for the moment, I'm just going to deactivate all this. And where's my close the workspace? And then safely remove. So this one's off. And I need a spot for it. I'll just put it there. And then close Thony off. And we'll pluck this. Now, I don't have a sticky note here. So those are those. And I'll just put this somewhere else over here. Now, I haven't prepped these two yet, I believe. So we're going to put a bootloader on them and turn them into CircuitPython devices. So we need a console prompt for a sec. We're going to need this. So we need to get it into programming mode. So that is like, there we go. Now we're in programming mode. So we'll just need to know what port we're on here. ACM device. ACM1. Okay. So I think I'm going to first flash this. And this is what I had happen last time. So this is what happened last time. I got stuck on doing the stub. Okay. Let's try this again. We're still getting stuck on the stub on these ones. That's the UART. Okay, try this again. Huh, that's strange. It's not doing what it's supposed to be doing. Let's try the other one. Okay, 0, reset, let it go, let go. We still on ACM1? Yeah, we are. Both of them is not doing it. Now let's change the baud. So okay, times 2. So and that is 230,400 times 2. Okay, 46800. Let's try faster baud rate. 46800. Wow, it's still not working. It should be erasing flash, and it's not doing that. Let's try the combined bin. Let's try this. No, it won't run stub. That's really weird. Well, we disconnected the device, so if we plug it in, it should not come up into programming mode. Right. So it's not in programming mode, so okay. That should have put it in programming mode, which it does. And it's still not doing it. Both of them. We are in ACM1, yeah. Okay, we have a problem here. These two new ones I can't program. I don't know why. D2I USB 0. Well, okay. That works. We come into the serial port. Okay. So it didn't come over to the JTAG port. Why? Used to use. Okay. Suppose I could have gone at a faster speed. There we go. Okay. I got a little red light here. And I think we'll change this to 480, 460, 800. Okay, so I flashed them. Now we need to get CircuitPython on them. Come on, there we go. Let's plug it into here. So we do have the Lolin boot right away, because we never had CircuitPython on here before. Duh. Okay, so we need the controller, and this is Lolin. Copy and over to Lolin boot. Oops. We'll delete the default one and we'll paste one file. The light is really blinking. Here we go, almost done. It's going to reboot. Should come up CircuitPython. Ta-da. One CircuitPython. Okay, that's one done. Let's do the next one. Okay, it should come up with Lolin again. So we'll delete this, we don't need it. Paste our one file again, it's still in the clipboard. Blink, 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 lots of blinks. Finish. Resets. Ta-da! One CircuitPy. Okay, so these are prepped. And they can go into that direct container. Of them. Now, got those controllers out of the way. We've done their screens. Now, a project I haven't put together yet, and I've been meaning to do it. Ooh, a little bent. This is that Bluetooth thing I keep forgetting to put together. There we go. So what do we got here? Oh, this is the package to put it together, and this is the actual electronics. So what do we got here? What's this? Power switch, speakers, wire cables, circuit board, LEDs, lots of LEDs. What else? We got more LEDs. Another LED, a resistor, another resistor, LEDs, caps, and a transistor. Okay. That's our circuit board. And since I always forget this, LED long leg is positive. So let's put the LEDs in first. Long legs are positive. It's supposed to be a Bluetooth speaker set, so we'll find out what goes on here. Did I put that in there? Yeah, I did put that in there. My helping hand, basically. I needed the soldering thingy to hold all this together. Whoops. Son of a bitch. Come on, guys. I like the LEDs with the stub that's really close to the LED, where when you slip it through hole, it holds it in place. This is not one of them. So I guess I'll be sticking these things back in again. Okay, there we go. I have to do my glasses off for this. Well, I could put the magnifiers on, but they're hard on the ears. I'm just doing one leg at a time here, just to get them all, because I know these LEDs are going to be crooked, and we'll have to straighten them out. Okay, let's see how crooked we are. Yep, definitely crooked. So what we're doing is just pushing down on the LEDs so they're flat. And just re-soldering the one leg. There we go. Now the LEDs are straight. Now we can do the other side. But I want this. There's our soldering. Okay. This way we can do a little higher up here. There we go. Okay, wow, my trash bin. Oh, so full so far. I better empty it out. There we go. Okay. Oh. didn't have quite the right grip on that to stop it from spinning in my face. If you don't wear glasses, I highly recommend you have something just in case. You don't want one of these little wires to flick into your face. They could actually flick into your eye too. So hold on to the wire when you snip it. Just don't blindly cut it. Otherwise you end up, it just happened to me. Here we go. Okay, here's our LEDs. So what's next? Probably, let's see, let's do the transistor. Transistor right there. This one's like a friction foot. There we go. Okay, that's the transistor. What else do we got here? We have 3 capacitors. Are they all the same? 10 volt. $100. 2 and 1. So they're not all the same. So we got here 2.2 microfarad and C1 at 100 microfarad. And this particular one I'm holding in my hand is 1 microfarad. So it goes over here. Negative lead is that way, so we have the 2.2. It's over here, and plus and minus, of course. These are, after all, electrolytics. Don't put them in backwards. And then we have this one, which is over here. And we've got the plus on the long leg and the negative on the short leg. Yeah. So put this back in our little stand here. Here we go. Okay, so let's see, Mr. Capacitor. I think I'll do one leg and then straighten out the capacitors, make sure. I might not have to. They're on pretty good. And there we go. Where's my little trash can over here? There we go. Okay, caps are in. Yeah, pretty good. As the saying goes, good enough for government work. So we have now this thing, the speaker. Speaker has a plus minus? Really? Didn't think it did. So it doesn't state it on the shell. But there's only one way it can go in anyway. It's this way. There we go. Okay, we have a switch. No, we have this pot here. We should actually get the resistors in here too. So what we have here, yellow. If William would remember his resistance code. The only problem with blue resistors, you can't tell which end you're going from. So like this one's really bad. This one is, from one side it's brown, black, black, red, brown. Or it could be brown, red, black, black, brown. I think it's going to be brown, black, black. So 1, 0, 100, and red is 2, 10K. I have a 20K on here, a 1.5 mega ohm, a 10K. Yeah, there is a 10K on here. And then we have our little okay, so what's our next resistor here? This one here, another 10K, I think. Red, black, black, red. So another 10K in here. 470, 1.5, 20K, spare 10K. This one is yellow, purple, black, black. Yellow leading being 4. So this is the 4. 4, 7. Yeah, I think that's what that one is. This is the 470. Oops. Actually, let's just turn this around so they all read from left to right. Like so. Okay, what do we got here? We got one more over here. And this one is, oh boy, brown, green, black, or brown, yellow, black. So what's brown, green, black? Brown is 1, green is 5, black is another 0. No, brown, green, black, yellow. Brown 1, green 5, that's 1.5. That's, is there a 1.5 in here? 120K, 10K, yeah, 1.5. This is the mega ohm one. So this will be the mega ohm one, right down there. And then the last one here has to be 20K. So Yeah, we begin with a red, so that's 2. Yep. Okay. There we go. Resistors are in place. What are the leads? These are 10 leads. Okay, then we have this resistor, sorry, potentiometer. That's going to go here. There we go. Okay, potentiometer, where are you? Oh, there you are. Okay. Now we need my glasses for a sec. We need the switch. Okay, so this switch, where in the heck does it go? It's quite the quick leads. Well, I don't see. Oh, I missed a piece. It's still in the bag. It's actually poking out the bag. Oh, that was great. All these leads are bent. So we have to straighten out all these leads and pray that we don't break one. Where's my pokey device? Okay. There we go. So what is this thing anyway? GM2291D. I don't think I have a spare of this. And we need this in here. No, let's find out if we can get it in here. No, we have a little bent lead problem here, and here, and here, and here. Let's see. How's that? Okay, let's try this again. Whoa, I think I got it in. Except now I can't find the solder. Not without my glasses again. There it is. Okay, so yep. Okay, so one more to go. Okay, the chip's in place. We have a switch, we have a diode, we have some leads. Where the frick does the switch go? Ground, VCC. So we have these three leads here, all the same. So I have this big rocker switch. Okay, so there's the front. Okay. So I guess this must go on the shell. Now why do we have a single wire here? And we have these four pads. Well, if all else fails, open the instructions up here. Okay, connecting wire. Okay, so wow, okay, that's not enough wire for that. So USB cable passes through the hole, red VCC, white ground. Oh. Ugh. This cable too. Okay, so the speakers, let's go to the speakers part. They get two of these. Okie dokie. Oh, such tiny little wires and such big little holes. Okay. And black, make a hook on it. Okay. Solder. That's one. Number two, make little hooks out of these. So hook. And then black over on this side. Okay, and a bit of a dent on here. Look at that bent speaker. There we go. So that's good. So the speakers are on. Okay. And according to this, power on the back side of this one, like the farther one. So ground, VCC, so like so. Okay. There we go. So that's the power one. Uh-oh, can't see anything. Glasses on, please. You move over there. Okay, so what do we have left? USB thingy. This one. Well, they have conflicting things because on this picture here, it's not the same as this picture here. It would have me switch the power on here, on this one, through the USB. Why? Why would you switch USB power? Just unplug it. So the middle diagram would have me do it without the switch. And number 10 would have me do it with the switch. USB cable passes through the hole. is not in the USB cable, so it goes there. White lead on the USB is ground. Red lead is power, but the red lead would go to one end of the switch. I think it's time to take the shell out of the bag and find out how to put all this thing together. So this guy here. Let's find out what's going on here. Okay, so we got these. Lots of screws. So we have to get all this paper off. This is so much fun. Okay. That's that one. There we go. This one's a little more stickier. There we go. Okay, that's one piece. And the other one. Here we go. It's one side, the other side. Whoops. There we go. There you go. That's another one done. Now these guys. It's getting a knife underneath the edge of this coating. There we go. There's one here. Here we go. That's that side. Let's take this one apart. Okay. Okay, that's another part. Take this one apart. Since you have more holes in it, it's harder to get it off. I wonder how they make the holes in here. Do they drill it in, or they laser punch it or something? There we go, and we have one little bit here. There we go. Now the other side. Okay, there's another one, so that's another sheet. Now these big ones here. Okay. So the other side. Oh, that one went easy. Except for that part. Whoops, I forgot the other side one too. There we go. This side. Okay. Let's see if I can get this edge without. There we go. One more. Okay. So according to the diagram, they don't even show this putting this together. So they would have me, oh, I see, a little bit of it. Okay, so we've got, and we've got, so I gather that this is, don't tell me to put the LEDs on backwards. Oh, they would have me bend the LEDs forward. Oh, I did screw up the LEDs. Shoot. Shoot, 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 shoot. These are supposed to go like this and poke through the holes. That's a dumb design. Where's the piece that this goes on? That must be the dip switch, and that must be the frickin' hole. Does that go through here? Yeah, it does. Probably the other way around. There we go. Like this. We have two screw holes here. They match that. So I guess that this might go like this. And this goes like this. Okay. But since we screwed up all the LEDs, we're going to have to fix them. And I don't really feel like fixing them right now. So we'll leave this at half done, and I'm going to take a break, and so my back is a bit sore, and I'll continue this in a bit. Not today, but I'll have to warm up the desoldering pencil and figure out the rest of this. Oh, there we go. So half assembled Bluetoothy. I know where I have to leave off on, so power switch crap. I'm pretty sure that that was this piece here. Something like that. Now, does that go on the outside or the inside? I don't know. So would that go here? And this one would go here like this. And this thing would be the back side. Kind of like that. And the speakers would end up going in the sides like that. So the speakers point, wow, okay. I wonder what this is for. They don't explain that. And this thing goes here. Oh, they go right here. Like so. Down inside. So if we were to just take this out for a sec, we go like this. This would go here, and this would go here, and then this. Like so. A little on the short side though. I don't see why we need them. Weird. I think they would have me strip this USB cable back a little more. I mean, it's not even a true USB cable. I mean, it's just a USB get power out of the thing USB cable. There's only 2 wires in it. So yeah, and I suspect this goes like this. And this one goes like this. And you would put that into here like, probably like this or something like that. And that would have to plug into that. You know, kind of like that. But I'll leave it at this. I'll have to fix this whole board. So, and I'll do that later. I can only sit at this seat for so long before my back starts to hurt. Okay. Okay. So I'll finish this, but not at this moment. Later.